Welcome to What is SS7, our 33rd monthly event covering technical, business, and partner topics to help service providers and enterprises build better voice networks. SS7, or Signaling System 7, is the dominant protocol used to control the public telephone network. Call routing, number portability, caller ID, mobile SMS, and more are handled using SS7 in the public network. SS7, along with SIGTRAN for transport, allow applications to access public network resources for call control and authentication. Stay with us as we share some background on SS7, show how to use it in everyday communications, and provide some use cases in popular applications. We'll leave plenty of time for some Q&A, so let's get going. I'm Alan Percy. I'm the Chief Marketing Officer for Telco Bridges, and I'm glad to have you here with us, along with Mark St. Ange. He's a Technical Director of Sales and our local resident SS7 expert. And Mark, thanks for joining us today and sharing some of your time and your expertise.
You're very welcome. Thank you for having me. I look forward to discussing the topic.
Great. Good. All right. So, quick review of the agenda. We've got just a couple more little introductions to go through. Then I'm going to start out with some background on SS7, move on to the network elements and discuss how they all fit together, some of the signaling functions that are part of SS7, and then we'll move on and talk about SIGTRAN for transport and why that's important and why people are adopting it and some of the use cases for both SS7 and SIGTRAN. And then we'll leave some time for your questions, and hopefully we can get this all done in 35, 40 minutes and leave you plenty of time for Q&A. All right, one quick intro. When looking through our registration, as always, we have lots of new guests, and just a quick intro as to who Telco Bridges is. We are a manufacturer of VoIP gateways and session border controller software, along with signaling gateways. You're going to learn all about that today. We're employee-owned, founded 2002. We got roughly about 40 employees at this point, and we're headquartered in Montreal and soon to move into a brand new building. We're excited about that. With our hardware software development is all done in Montreal, and we have sales support offices not only in Montreal, but Turkey and Hong Kong, and I work from my home office just outside Buffalo. And we, with those offices, those sales support offices, are able to offer 24/7 technical support for our customers, which many customers find quite valuable. One of the other areas we got to include is our, our wins slide, and this is just a quick sampling of some of the service providers around the globe that have leveraged Telco Bridges technology, whether it's gateways or signaling gateways or session border controller technology. Really a global carrier network solutions offering, and very focused on reliability and service. This is one of the important tenets of Telco Bridges, to provide top-notch quality solutions for the service provider market space. And along with that is some innovations, and of course, if you've been following our webinar series, you've heard about all kinds of interesting things people have done with our gateways and SBCs as they've deployed them. All right, so we're going to start out with what is SS7, but first we got a little quick poll question for everyone just to sort of get a gauge on our audience here. So I'm going to push a question out to you all, which is, which of the following best describes your work with SS7? Do you have an ongoing project using SS7? Are you planning a project with SS7? You don't have a project right now, but you want to learn about SS7, or maybe you're just curious and you're a regular follower to our sessions. So we'll just give you a minute here to answer these questions. All right, so hopefully that popped up. You can see the results. We've got 30% of you have said you have an ongoing project, 10% of you said you're planning a project, 51% of you said there's no project, but just want to learn about SS7. And another 9% are just curious. So that's great. That's we're thrilled to have you join us, and it helps us understand where you all are. So excellent.
And Alan, that's great because the webinar is educational.
Yep, that's perfect. So it looks like we got the right audience here today. All right, so let's move on. So, Mark, I'm just, we had talked in advance about some of the challenges with SS7 is helping people understand how important it still is to the current network. So, why don't you explain why it's so important?
Yeah, for sure. I can. SS7 is a global network, and initially it came into existence in order to have a better way to control the establishment and tear down of voice calls. But over time, it's a high performance network. It's very reliable network, and it took on other functions, such as the transport of SMS, such as support for mobile phone roaming. And what's amazing is that the protocol is, let's say, about 40 years old, and it's still growing today.
Yeah. Yep.
And the main reasons why it's growing is because, well, there's more and more SMS traffic, there's more and more roaming, and there are more mobile virtual network operators, and they all use the SS7 network.
Yep. Yep. Oh, it is interesting to see that continues to grow. And we're going to talk about some of the ways that it continues to grow as we go through today's deck. So it's great. So then the next step really is let's just start at the beginning. Well, maybe not this far back, but I found this cool picture. I thought it was pretty interesting from the Montreal Telephone Exchange, and those original operators. But let's skip ahead a little bit in time. Let's go to the 1970s. And the 1970s brought all kinds of interesting innovations, right? Space flight, the oil crisis, digital computing age, the growth of telephone service, right? At this point, by now, most everyone was having a phone in their home and business. Global telecommunications, people being able to call across the globe, and the adoption of digital telephony. And that was part of the reason of the birth of SS7. And Mark, I'm just sort of curious, digital telephony, was this voice over IP already?
Yeah, of course not. No, it's the digitization of voice, the encoding of voice in order to transport it on digital circuits instead of on analog circuits. In fact, the SS7 started with AT&T in 1975. But then it was adopted globally starting in 1980 with the CCITT, which started issuing standards for SS7 signaling.
Right. So its history is deep, and it came to be in a world of mini and microcomputers and digital telephony. So as we started, studying this, and I'm flipping through that textbook, this was an important concept. I think that's important to understand, is the difference between channel associated and common channel signaling. So why don't you walk us through this, Mark?
Yeah, sure, I can do that. So there are two ways to carry signaling for voice communications. One is, as we're showing here, is channel associated signaling, where the signaling information, which its aim is to establish telephone calls, but also tear down and supervise telephone calls. This signaling information is carried within the voice path. North Americans will know about T1 robbed bit signaling, where on T1, which carries voice, we can rob one bit from every time slot in order to pass the signaling information. Others in rest of the world, they may know this more as R2 signaling, where we don't rob one bit in each time slot, but we rob one time slot in each E1 to carry the signaling. So what that does is it makes for an inefficient use of the circuits that are established to carry voice, because you're stealing bandwidth to pass the signaling. but also it makes it vulnerable from a security point of view.
Right.
Because you're carrying the signaling in the voice path, and the actual caller and callee have access to that voice path, and they can ultimately inject signals in there and alter the signaling. So it was found that it would be much better if we use the technology of common channel signaling, where we take out the signaling from the voice path and establish a path separate from the voice circuits to carry the signaling. In this case, you get more bandwidth, you can secure the communications, and you get higher performance.
Got it. And I think we kind of summarized that here with some of the real pros and cons of the common channel signaling were much more efficient use of the voice path, right? So the voice path is unencumbered with the signaling. The signaling's through a different separate circuit.
Right.
This leaves more bandwidth available for the signaling then, right? You're not trying to squeeze it into a voice channel and try to rob bits and do those kinds of silly little tricks. Instead, now you're able to have a dedicated circuit for it. As you mentioned, it's more secure, and also it gives you more flexible architectures. And I think as we move forward, that'll be more evident.
Yeah, that's right. And I'd like to add one more thing, is that it makes the voice network, because here we're at the time when SS7 was invented, we're focused on voice communications. Sure. And the other thing it did is that it improved the performance of the voice network, because you get more bandwidth in the signaling path to carry more information, but faster also. So right. it reduced the call setup times very much. And it was a significant move ahead for voice networks.
Got it. Good. Okay. So let's get into some of the architecture and the nodes, and we're going to start with service switching points. And these look like they're attached to these two exchanges here in the diagram. So you want to walk us through this?
Yeah, for sure. So the service switching point is a technical term in SS7 lingo to mean a telephone switch. Also called an exchange. Here we're showing exchange A, exchange B. These are voice switches that provide voice services to subscribers. And in joining these two nodes, we have a number of voice paths that actually carry the voice, but we also have a signaling path at the bottom there, shown by the two green lines. And we show two of them for redundancy. You know, the SS7 network is very reliable, so we're always concerned about redundancy when establishing an SS7 network. So this is why we show two links here. And the way this works is, you know, if a subscriber on exchange A is calling a subscriber on exchange B, the signaling to bring up the voice path on the orange links up above is performed on the green links below, and it uses the SS7 protocol and at a higher layer, specifically ISUP, in order to set up the voice path.
Great, good, yeah. And the link sets, it's some terminology that's focused on links always work usually in pairs like this. And I think as we go later in the deck, we'll see how that's handled. That's great. Good.
Yep, that's right.
So then let's talk about addressing. You know, today we use IP addresses to talk about, you know, the different nodes on an IP network, but of course this predates all that. And they had a little different addressing mechanism, but basically it's the same idea, right? There's a set of numbers associated with every single node in the network, and those are point codes.
Exactly. It's the equivalent of an IP address in an IP network. Every SS7 node is configured, identified by a point code. And in the ITU countries, well, in the countries where we use the ITU standards, the point code has 14 bits, and in North America, the point code has 24 bits. And for example, those two switches on the previous slide, they each have their own point code. And when we want to establish a call or send a message from one to the other, we address it to the destination point code, just like we have destination IP addresses and source IP addresses in IP networks. So the actual addresses, the format of the addresses are different, but the concept is the same. But I like to point out one thing here that's interesting. In the SS7 network, all routes are statically configured, whereas we know in an IP network we use routing protocols where the routes can change dynamically. But in an SS7 network, that's not the case. It's very deterministic, and SS7 network managers configure each and every route in an SS7 network.
You know, another thing too, there's not a lot of bits in this address, compared to what we've done with IP, and IPv4 and IPv6. I guess this really kind of limits the size of the network overall, but it's all just service providers. So I guess that's part of the challenge, right?
Yes, that's right. And you bring up a good point. The SS7 network, we can say, is a private network, right? It's only used or only accessible, only used by service providers. Enterprises, you and I, Alan, we don't have access to this network. It's private amongst worldwide service providers. And so, yeah, I think it makes it like it's a smaller network than the IP network in terms of nodes, right? But it's still very essential to communications still in our day and age today.
Great. Okay, so let's move on then to adding signal transfer points. Now, if they have to go from point A to point B and also point C, how do you get from point A to B to C?
Yeah, so another important node in an SS7 network is an STP, signaling transfer point. The STP acts as a router for SS7 messages. In this simple diagram here, we see that, instead of having fully meshed SS7 links between exchange A and B, A and C, and B and C, we can go through a signaling transfer point, an STP, which will route the messages according to the destination point code. And this diagram is really simple one, but what the STPs do as well is that they avoid the necessity to establish links between every SS7 node to every other SS7 node. So it reduces the complexity of the network in a way, and reduces the cost of the network also. STPs also perform other functions, and I'll just mention them, such as global title translation and gateway screening, which, let's say, can aim to protect the SS7 network from unwanted traffic and things like that. But basically, the STP is a router for SS7 messages.
Got it. And now we add another element to the vernacular and the puzzle, which is the service control points. And what's the role of a service control point?
Yeah, the SCP, and this is the last node, that's part of SS7, which is quite interesting, I find. There are only three different types of nodes. Well, the service control point is an SS7 node which delivers a service. Okay, it doesn't switch voice. Okay, it doesn't deliver a voice service, but it delivers a service to the SS7 network and to the SSPs that are on this network. And examples are given here, such as it can hold a caller name database, can hold a local number portability database. Service control point can also be devices or architecture elements from mobile networks, such as VLR, HLR, that have the database for where the mobile phones are located and what services they subscribe to. An SMSC, a short message service center, is also an SCP, and the SMSC is a device on a mobile network that initiates and receives SMS messages in order to deliver them to mobile phones. So the way this works typically, okay, is that depending on the service that's to be delivered by the SSP may query the SCP for some information to, how would I say, to deliver the call appropriately. Maybe by, for example, presenting the caller name to the callee. And that's how the SCP is used in the SS7 network.
Great. Yeah, I know we got an example here in a couple of slides, so it's great. Very good. All right, so of course there's a protocol, right? To go back and forth, and that's, you know, SS7, but it's divided up into layers and smaller little chunks, and it looks like it's aligned with some parts of the OSI model. Can you walk us just through these real quick?
Yeah, I can say that it's somewhat aligns, you know, with the OSI model, but not exactly. So if you're familiar with the OSI model, it has 7 layers shown on the left here: physical layer, data link layer, network transport, and so on. This slide is, let's say, not technically precise, but good enough. You know, in that the application here for, let's say, the ISUP protocol is really a voice call. You know, but the main layers of the SS7 network that are involved in delivering messages, transporting and delivering messages from one node to the other, are MTP level 1, level 2, and level 3. And so at MTP level 1, typically in North America, we use T1s. In other countries, we use E1 to establish the physical layer, and the MTP2 level 2 is defined by the SS7 standards as a way to reliably establish a data link layer across the T1 or E1 to reliably be able to transport messages from one node to the other. And the MTP3 or MTP level 3 is involved in addressing, you know, much like the IP layer in TCP/IP. And that's mostly involved in addressing, but it's also involved in maintaining the connection, informing, you know, other nodes that maybe this link is down or this point code is not reachable or this kind of thing. And then the upper layers are involved in carrying the useful signaling information for what we really want to achieve, which is, for example, setting up a voice call or carrying an SMS, you know, from one mobile phone to another, or maybe querying the local number portability database in North America.
Excellent. Good. And we brought along a little example of what it looks like. And again, I lifted this out of the textbook, but the I think this diagram shows an ISDN caller at one end and an ISDN caller at the other end, and the ladder diagram of the messages that go between the ISDN and the originating exchange, a transit exchange, the terminating exchange, and eventually on to the target of the call. A bit of a eye chart, but I think it gives a general gist of what happens here in the sense of, a call setup causes a set of messages that pass through the network, eventually on to the destination, and a number of acknowledges that come back.
Right. I'd like to say that in this call flow, the SS7 messages, the SS7 ISUP messages, because this signaling aims to set up a voice call, right? These SS7 messages are the ones in the middle, okay, between the originating exchange, the transit exchange, and the terminating exchange. And the other messages on the leftmost and rightmost, these are ISDN signaling messages. So what we see here is, on the left side, some ISDN user, maybe, someone in the office, picks up the phone and dials. Well, the PBX from the office on ISDN PRI will send a setup message, which will cause the originating exchange to send an initial address message or an IM based on the routing, the call routing that's configured in the exchange. And this message will end up sending another IM to terminating exchange, and all of this is in order to set up the voice path, which ends up being set up at the end after the last connect message on the left there. So these SS7 messages in the middle, there's the initial address message, which is the equivalent of a call setup message. There's the address complete message, the ACM, which says to the originating exchange, okay, I've received, your digits, I've received your call, and I'm ringing the far end. And then finally, when someone goes off hook, there's an answer message, the A&M message, which ends up establishing the voice path between the two callers.
That's quite a bit, and all that just for dialing a telephone number. So,
yeah,
it works, right?
Yeah, right. And I'll just say a little thing here. I left out this SAM message or SAM message because it's a bit of a particular case, where the ISDN exchange is doing overlap signaling, and not all of the digits, of the called number are being sent at the same time, in one block. But it's a detail.
Yep. Interesting. Well, it's a peek under the covers. Hopefully you'll never need to see again. But then it gets complicated, and then we start to bring all those nodes together and take a look at the real world. And I think this is a peek at how the typical SS7 architecture is deployed. So walk us through all this.
Yes, right. So this diagram shows, a larger sample for an SS7 network architecture. What we see in the middle are 4 STPs, 2 pairs that are fully mated. As you can see, the SS7 links in green there in between STP 1, 2, 3, 4 are fully meshed. We have B links, we have cross links, we have D links. By the way, here we label them as D links, diagonal links, but some people will argue that instead of D links here, there should be B links, where D links are used to interconnect STPs at different layers in the different hierarchies in the SS7 network. But you find both in the industry. The other thing that you see in this diagram is that for the voice switches on the left, SSP A, B, and C, you see that they are connected to the SS7 network using A links, access links. They are always redundant. As you can see, there are 2 of them right? That go to each to a different STP for redundancy, because the signaling is at the core of the network. You want to be sure that if you lose a link, you lose an STP, that your SS7, your access to the SS7 network is still up. And this is why we do that, and we do the same for SCPs there on the right-hand side. The only thing that's a bit different here are the F-link at the bottom left, where not necessarily redundant, but we don't, well, at least in North America, we don't see many of these F-links, but they still exist. But for everyone to, say, picture this, and maybe relate it to real life, okay? The nodes on the left, the SSPs, are voice switches. We've identified class 5, class 4, or maybe a mobile switch. Well-known switches like these are, the Nortel, DMS100, AT&T 5ESS, 4ESS, Siemens EWSD, Metaswitch, Nokia switches, and many others. And in almost every service provider network of a certain size, you'll find an STP pair, which is used to serve these switches on the left, but is also used to interconnect with other service providers that also have an STP pair.
Right.
And you can multiply this by 100, right, to get an idea of how the worldwide SS7 network is interconnected.
I can see it quickly grows in complexity, but with all the redundancy, I think that I think gives a good taste of why this network is hard to kill.
Yeah, and I'd like to add one thing, if I may. So if we focus, for example, on let's say the SSPA that has one A link to STP1 and has one A link to STP2, okay? Not only are these links redundant, when they go to different STPs, which is great, but these links are also over-engineered, which means that under normal conditions, the maximum traffic load on each of these A links is 40%. In, let's say, a well-designed network, maybe 50%. Okay, and the idea there is that if you lose one of the links, well, the other one can take the full load, right? If you're load sharing, almost half of the traffic on each one, if you lose one, well, then the other one can take the full load of traffic as if nothing happened.
Wow. Interesting. Okay. So let's move on and talk a little bit about one quick use case, which I think one of the topics you had talked about is retrieving the caller name, and one of the applications it comes up fairly often is for a user application to be looking to retrieve or convert from a telephone number to the caller name, and there are a number of services that offer this, and this architecture here just kind of gives a glimpse as to what happens for those user applications that are going to use an API to retrieve the caller name. So Mark, let's just kind of walk through the steps here, what this CNAM gateway is and how it relates to the nodes that we've already talked about.
Yeah, right. So in this example, the caller name database resides in a service control point somewhere on the SS7 network. This is shown here on the left-hand side of the diagram. On the path to reach this caller name database, there is one or more STPs involved in the SS7 network. And what this is showing is allowing an outside application access to the caller name database. Because we said the SS7 network is, say, private between service providers, it's not accessible to enterprises or other entities unless there is a gateway which will convert, let's say, an API query, maybe using HTTP, to the caller name gateway, will convert it to an SS7 message. It's really a TCAP query. If you recall there, the layers, there's a protocol called TCAP. A TCAP query is the API command is converted to a TCAP query, which goes out and gets the caller name and reports it back to the user application. This is an example of how more and more of the SS7 network is becoming accessible to other entities than service providers, but I'd say always through some sort of gateway. Right. And, now, like on mobile phones, we're using two-factor authentication, or you access your bank account online, and you log in and the bank tells you, well, enter the code we've sent to you by SMS. It's the same idea here, except for, caller name. It's sending an SMS message. So there's an API somewhere on a gateway and someone providing a service that allows sending or receiving SMS messages from an easier to use API, than actually having an SS7 node on the network.
Right. And we have a number of partners as part of our alliance partnership who have these kinds of APIs and have access to these elements. But the point being is that they're working with a gateway provider, one of those, an actual service provider who is giving them access through this API to get at the core of the SS7 network. They don't directly themselves go after it. So anyway, yeah, number of partners. CNAM's one of them. I think SMS is another good example. Those are all good use cases for accessing the SS7 network.
Yeah, that's right.
All right, so let's talk a little bit about SIGTRAN. And again, we got another little quick poll here. So let me just pull it up real quick. I'm just going to ask you guys questions about the poll and share the results. So which of the following best describes your work with SIGTRAN? 16% said you're working on it, 11% said you're planning on a project, 59% said no project, just want to learn about SIGTRAN, and 15% are just curious. So that's great. So thanks everyone for responding to our poll. And let's move on then and talk about SIGTRAN. So SIGTRAN, Mark, is an extension of SS7, or it's another method for transferring SS7. So walk us through these other protocol stacks that you've added here to the slide.
Yeah, that's right. So the SIGTRAN is a set, is a set of protocols for the transport, mainly of SS7 over IP. And it's defined by the IETF, and it defines protocols such as M2PA, M3UA that you see on this slide on the right hand side, but it also defines other protocols such as M2UA, IUA. But in terms of SS7 signaling for voice and for SMS, or the applications we're discussing here, the two main protocols involved are M2PA and M3UA. So what you see here, we're showing here below the label SS7 is the signaling protocol stack we saw early on a previous slide. That hasn't changed. And we're showing on the right-hand side the SIGTRAN protocol stack. And what we see is that, the upper layer protocols don't change. What changes is how they're transported. The physical data link network and transport layer in some cases, right? So the idea here is to use IP or use the data network to transport SS7. When we discussed it earlier, we said, MTP1 is T1 or E1. Well, in this case, the physical layer is very often Ethernet. The network layer is IP, but we're adding another protocol here, which is SCTP, which is there to guarantee the delivery of the messages and to guarantee them in the right order. And then the standards define two other protocols in this specific case here, M2PA and M3UA, which defines how they interact with the upper layer protocols and how they interact with SCTP. So sounds, rather complex, okay? But the only objective is to be able to carry the SS7 messages, the application messages or the user messages, carry them over an IP network instead of over TDM.
And what's great is we have an example later, a different slide that explains why. So I think you added this here to provide some clarification. As you said, they're defined by the IETF, SCTP. There's an RFC that defines that. Same thing too with M2PA and M3UA. There are RFC specifications for those. Not many people, I guess, really get involved at that level, but I think it's important, right, to understand that this is what's going on underneath the covers in the conversion from those high-level ISUP messages to transport them over IP.
Yeah, and the idea is just to say, they're just other protocols, and you can read about them here, and their purpose is to carry SS7 over IP. Then after that, you can get into details when to use M2PA, when to use M3UA, and but then when you get into the nuts and bolts of it, you can figure out which protocol is best to use.
Right.
And Alan, and also depending on the SS7 nodes you're connecting to, right?
Yeah, probably. I would imagine they tell you that you're going to connect using this protocol, and you have to use that, right? Yeah,
and it depends on the devices. Also, some of them, they just don't support M2PA, for example.
Right. Yep. That's a good example. All right, so why would someone use SIGTRAN? This is probably the question, right? Why would you want to transport SS7 over IP versus over traditional SS7 links?
Right, and I would say there are the main reasons are that TDM links are, I think many will agree, are becoming more and more expensive. Service providers who are providing these point-to-point TDM leased line connections across a country or between countries or in the USA from state to state. I think what's going on is they're increasing the price for leasing these dedicated lines, these dedicated T1s and E1s. So as going forward, the price, the recurring cost is increasing, I would say. Right. The other thing is that, the IP network or the internet or private IP networks are now ubiquitous. It's almost available everywhere in the world, and they've proven to be very reliable in most cases. And so it's possible now to use an IP network to carry SS7. The other thing also is that the use of an IP network provides a lot of flexibility. If you wanted to one day change your SS7 connection, from one SS7 node to another that's in a different state, for example, on an IP network, it's a matter of configuration. You configure a new IP address to reach a new destination, and essentially it's done. But when you're on TDM, you have to place an order for a new TDM circuit between 2 points, and there's going to be a lead time. Maybe it'll be 4 weeks or something like that, depending on who you're dealing with. So those are, say, the main advantages of using SS7 over IP. And so service providers are interested in, one, migrating from TDM to IP, two, enabling their existing STPs to support SS7 over IP, that is SIGTRAN. Three, service providers are interested in replacing their STPs with something that supports SIGTRAN and has ongoing support. Other service provider, in the fourth example here, they want to connect to new SS7 networks, maybe, for example, to support applications such as sending SMS messages for two-factor authentication, for example. And finally, some service providers are just simply forced to move off of TDM networks, and the solution is to use the IP network instead.
Yeah, and we covered all 5 of these in great detail in a webinar that we did a few months back, and we'll be sure to include a link to that into the follow-up email. And it's a great module if you really want to understand what each one of these use cases include. As a matter of fact, we brought along one of them, which is the first one, and I think you pretty much covered this, but this diagram here explains just real quickly, the structure of how someone would replace one of their hard links, their TDM links, with an IP network, and the role of one of our TSG 800s.
I'll do it quickly. What we see here is on the left-hand side, there's a voice switch that has 2 A links to 2 different STPs, what we saw previously. And what we're doing here for some service providers is using Telcobridge's TSG 800 product as a signaling gateway to enable this switch to have one of these A links over the IP network instead of over a TDM network. And like I said, the idea is to reduce your recurring costs for that TDM link and use often the higher reliability that's available on the IP network than on the TDM network. There's always that story of the backhoe, who digs out the cable.
Yep.
It can happen in the IP network too, but usually there's additional redundancy that's built in.
Right, and the IP network's more self-healing, so good. Yeah, and again, we cover this in much more detail in the other webinar. So that transitions us to a quick overview of some of the solutions from Telcobridge's on SS7 and our TSIG product line. And so, Mark, why don't you walk us through the TSG 800, which we showed in the previous slide, and the TSG 3200.
Yes, I'll do that. So our TSIG product line mainly consists of 2 products, the TSG 800, TSG 3200. The difference between the two, Alan, is the number and the types of TDM interfaces that are available. But typically in the deployments of these products, we use T1E1s to connect to SS7 TDM nodes, and we use the IP ports, the Ethernet ports on these boxes to connect to IP networks in order to use SIGTRAN. These products are used in two applications: signaling gateway application, where they bridge SS7 on TDM to SS7 over IP using SIGTRAN, but they can also function as a signaling transfer point, as STPs, in order to route SS7 messages between SS7 TDM links and SS7 over IP using SIGTRAN.
Got it. And of course, here's just a close-up on the TSG 800, talking about its physical interfaces and the network connections. I guess to give a little bit more detail here.
Yes, but just briefly, you know, some of our listeners here may be interested in some of the technical details. You know, the products has certain limitations, so it's not appropriate for all SS7 applications, but here are some of its capabilities. On the TDM side, you can connect up to 64 SS7 low-speed links on the device. It can support up to 64 SIGTRAN associations, which means communicate with up to 64 SIGTRAN 64 SS7 nodes on the IP network, and it supports a certain number of SS7 routes. You know, this is in an STP application where we said the STP is a router for SS7. It supports a certain number of routes to route messages, and it supports global title translation, which is often used when communicating with SCPs, you know, such as HLRs, VLRs, SMSCs, and different databases that are available on the network.
Great, good. And again, there's more on the telcobridges.com website. So, which brings us to our additional reading. As I mentioned, we've got quite a bit on SS7 on the wiki, which is docs.telcobridges.com, the TB Wiki SS7 section. Also on the product on the TSG 800, there's a link to the actual landing page for that particular product. And we've also got a landing page if you're interested in learning more or want to figure out how to implement something within your network. We certainly would love to be able to help you with a consult, and there's a landing page for that. And again, we'll include all these in the follow-up email, so there'll be plenty more. In addition to that, too, also, you know, we talked about that other webinar, but there's another 31 recorded YouTube sessions from previous sessions, from training to the webinars to some tutorials on how to do installations and manage things, some customer interviews, FAQ, podcasts, and a lot more on our on the Telco Bridges YouTube channel. Go to youtube.com/telcobridges and be sure to click on subscribe, and then you'll get notified every time we add a new video. And we added quite a few. We add, you know, a few every month, and sometimes they're bits and pieces of other sessions. Sometimes they're the whole recorded webinar. So I encourage you to listen in. And with that, I know we're running a little long here, but we do, we've got a whole host of questions here. I think, Mark, it would be good to just go through some of these here real quick.
Sure.
Yeah, one is Richard notes that the ITU issues recommendations, not standards. So thank you for correcting us. That's
correct.
Kind of you.
Yes.
Yep.
Yes.
Michael asks about, you know, SS7 was stir shaken, and to limit robocalling. And Michael, thanks for asking that question. I got your question ahead of time. But as far as I know, the two are completely separate. There is stir shaken is only over the IP networks, and has no interaction with the SS7 network, unless, Mark, you know something I don't know.
No, so far that's the case. But I've been I haven't participated in discussion, but I've witnessed a discussion where, some experts were putting forward that, maybe we could use the SS7 protocol to transport, some stir-shaken information or to play a role into blocking robocalls. But as far as I know, it's just talk.
Yep.
Or ideas,
I think one of the ideas was, using that API environment that we showed earlier would be a way for a fraud detection system to be able to go in and see in the SS7 network what is the true origin of this call, and that's a completely different method, and is a different methodology for looking for robocalls. So the question about the links, it's two of them. Is it just redundancy or is it full duplex? And I think the answer to that is not only redundant, but both of those links are full duplex in the link pair. So,
right.
Mr. Anonymous asks a question: so, does SS7 become obsolete with a rollout of VoLTE and RCS instead of SMS?
I would say I think absolutely not. The use of SS7 is growing worldwide, and we saw earlier maybe close to 4% per year. Rich communication services, as far as I know, don't use SS7. But one thing people should know is that when you turn on your mobile phone, okay. You are using the SS7 network.
Right.
There's signaling that goes on between the mobile phone and the mobile network, and it uses SS7 protocols. And then beyond that, to the HLR, SS7 is used. I really don't see it becoming obsolete anytime soon.
I am seeing that this is the top of the hour, and I know some folks have to move on, but we are going to continue on. There's still quite a few questions here. We'll move on and answer the rest of the questions. And then if you receive, when you receive your link to the recording, you can skip ahead to the 1 hour mark and you can keep listening to the questions as you go. So we'll keep going here. All right. So Ricky asked a question about small cellular operators using their MSC as an STP. If you want a standalone STP, what product do we offer? And I think you answered that with the TSG 800.
Yeah, right. Usually the TSG 800 will do the job for such applications. Yes, it can be used as an STP, and it is often used in small mobile networks, just like Ricky mentions here.
Sure, that's great. All right, so Ricky also asked if you have, can one have an IP-only STP? In other words, interconnecting with SS7 over IP or SIGTRAN only?
Of course. And, the reason for that is that, SIGTRAN doesn't change anything with regard to SS7 signaling. The only thing it changes is the transport. So we can have an IP-only STP, and in the industry, they're called virtual STPs. And so we just use SIGTRAN as a transport, but the function of the STP, which exists to route SS7 messages, is still necessary, and it still exists even if you're not using TDM.
Good. Okay, so question comes from Anonymous. Any of the SS7 devices support SMS? And I guess that SMS is an application that rides on TCAP, so the answer would be?
The answer is yes.
Yeah.
But I will qualify it a bit. Sometimes a question like that is being posed in the sense that, can I use your device to send and receive SMS messages? Our devices do not provide an API, to originate SMS messages or to receive SMS messages. Our devices transport SMS messages by routing SS7 packets, SS7 messages.
But it would make sense, right, to find an API layer of software that puts SMS messages into a SIGTRAN format, then drop it onto a network and then transport it.
Right. So we have customers that use our products as a signaling gateway, okay, to connect to the SS7 network on one side and to provide SIGTRAN interface on the other for such a device or such an application that can originate and receive SMSs on SIGTRAN, right? And that application presents the API, which is, we discussed, Alan, maybe just a CSV file of a list of telephone numbers and the short message to send, right? It gets uploaded to the application. The application puts together the SIGTRAN, the SMS message to be transported over SIGTRAN to the signaling gateway, which bridges it to the SS7 network so that you can finally receive it on your mobile phone.
Yep. Basically what we showed in that one diagram. That's great. Yep. Good. So Mark's got a great question here. He says they're a small telco and have two SS7 links going to our upstream telco provider. So the one diagram as you showed earlier, right, would have two hard links, TDM links. Is it possible to drop both the SS7 links and move these over to Ethernet and have different paths, possibly bypassing the upstream telco provider?
Yeah, I think the answer to this is yes. If Mark, if you have an SS7 connection to your upstream provider, it's because you require this connection to the SS7 network. But of course, you could set this up to bypass this upstream provider, but it'll still remain an SS7 connection, right? It's mentioned, could we use Ethernet? And yes, use Ethernet, IP, SCTP, M2PA or M3UA, the SIGTRAN layers. And yes, bypassing the upstream provider, allowing you to connect to another provider of SS7 connection. Right. It seems to me that a connection to the SS7 network is required here.
Okay. Jeremy asked a question. I think this is in the back of everybody else's mind. Will the amount of fiber being built allow for more broadband? Do you think SS7 is close to end of life as a protocol?
Again, I'll say no. and it's not, and it's not because there's a lot of fiber. It's a good thing that there's a lot of fiber. In my opinion, we'll just see more SIGTRAN.
Right. It's just it'll shift over to SIGTRAN over IP instead of the TDM circuits. But the signaling protocol itself, because it's such an integral part of the way the public network works, it would be a massive change to replace all that. And I think that's probably part of the puzzle. So,
right.
Let's see a question here from TelExchange. Question is, can we migrate old version to one or fully change the setup if we migrate to it? Not exactly sure what the question. Can we migrate an old version to the new one and fully change the setup if we migrate to IP?
I think this Alan is a question from a Telco Bridges customer, and we'll be pleased to answer it, but separately.
Yeah, I think that makes the most sense. Okay, we'll skip over that. All right. You mentioned ISUP earlier is working with SS7 at a higher level. Can you elaborate on ISUP? So what does ISUP do? Maybe I think that would be I think you mentioned it a couple times, but it would be good to maybe just recap it.
Yes. So the ISUP layer of SS7 signaling is involved in the control of voice, establishing and tearing down voice paths.
Right.
Okay. Remember the ladder diagram you showed, the call flow you showed, and there was the signaling messages in the middle. There was the IM message, the ACM message, and so on. Those are ISUP messages that are carried by the lower layers of the SS7 protocol. So the ISUP protocol is part of the SS7 signaling stack, and its purpose is to control voice communications.
Sure.
I think that's what I'll say about ISUP.
Okay. And one last question here for Oded asks the question, does the TSG 800 support SMPP as well?
The answer is no.
Yeah. What is SMPP? That would be good to probably explain.
Yeah, the SMPP is a protocol to carry SMS messages over IP. It is different from SIGTRAN.
Right.
Okay.
Probably if somebody had SMPP, they'd have to use a gateway, like we talked about in the API slide, to translate from one to the other before it goes into the SS7 network.
That's exactly right.
Right. Good. All right. Well, I think this is just a couple more questions here. We're getting almost to the end of the list, and I appreciate, there's 100 people still on this call right now listening to the questions.
Cool.
So yeah, we'll keep going here. Do you think that the future SS7 is for them to consolidate into virtual ones by moving to VoIP and SS7 in the cloud? Looking at the old rural telco point of view, you see any trends like this or something else? And I think what's interesting is it seems like a natural transition, right, to move all the SS7 network eventually over to IP links. But what's interesting is some of the rural telcos have got some issues with those T1s, the old TDM T1s, and availability of them. That's probably going to hasten some of this change, right?
Yeah, right. I think so. I think the question is about the future of SS7, and for the SS7 signaling, or network to be consolidated into the cloud. Right. I think yes, there's some of that happening. Right. Many STP vendors have offer virtual STPs, that is software-based STPs that can run, on dedicated servers, or they can run in the cloud. And we also have some SS7 providers that are offering their service from the cloud. So yeah, I think it's happening. But the question for Mark is, looking at it from a rural telco point of view, I think, yeah, for sure, it's possible. But I think for such telcos, there's still there are a few challenges to resolve. It depends to what extent you can convert your access lines to IP, to what extent you can convert your emergency lines to IP, your connections to your 911 service providers, your connections to the other service providers for your interstate traffic or your long distance traffic or international traffic. In many countries around the world, those interconnections between service providers are still SS7 based using TDM circuits. But I think it's going that way, Alan. But yeah, it's going to voice over IP, and everything over IP, including SS7 over IP, but it's going slowly.
Yep. And every one of those transitions invariably ends up with some kind of gateway somewhere. And so that's why we've been so busy lately, right? So It's good news. Anyway, and last question. Andrew asked a question. He says, "Good morning." And yes, good morning, Andrew. The ATIS is starting to work on TDM network call authentication with stir shaken for non-SIP networks, and that's a great point you make. It's somewhat unrelated to SS7, but is absolutely something that we've been working on. Matter of fact, we did a webinar 3-4 months ago, I think, with TransNexus to talk about out-of-band stir shaken. Where the idea being is that a TDM call comes into a gateway, and then the gateway then uses a call authentication service to create a certificate that it puts in a public storage place. And then when it gets to the destination network, that the equipment at that end, if it could be a switch or a gateway or an SBC, when it gets to the destination, it can then go and find the certificate for the call, and then the token for the call, and then authenticate the origin caller ID information. So it's a very important part of stir shaken to help make it become popular. And like I said, we covered that in one of our other webinars, and I would kind of refer you to that. But it doesn't seem like there's much overlap with SS7 other than, after this gateway, the call might end up being transferred into an SS7 network as it traverses the TDM network. But by then, the token's already been posted in the public area. So anyway,
Yeah, right.
with that, here we are, an hour and 15 minutes into it, and I want to say thanks to everyone. There's 94 of you still listening. Thank you so much for sticking around. And Mark, I want to thank you too for sharing your expertise and knowledge. Obviously, a hot topic that a lot of folks joined today and listened in, and do very much appreciate your contribution, Mark.
That's great. Really enjoyed it. It was a lot of fun.
Yes,
I love talking about this stuff.
Good. We can tell. Anyway, I want to thank everyone for listening today. And as I mentioned before, by registering, you'll get a copy of not only recording of this call, but also a link to the slide deck if you'd like to take a peek at it on SlideShare. And with that, I'm going to say, everyone have a great day, and we'll see you next month.